Go ahead and run through this last part. This is all algebra review. So again, this is probably going to be the fastest part, so let's just get to it. So we want to round to the thousands place. I'm even doing a favor and saying 3 decimal places. And so we have to round, so we had basically cut off the last few numbers here. So we're going to round to this place, and we know that the next number in line actually informs us of that. It's a 5 or bigger, then we round up, otherwise we keep it the same. A 3 is not enough to increase or bump up the round, and so this will just be 3.459. Same rule here, we're rounding to that place, look at the very next number, 5 or bigger is the rule, and so this will round to 10.195. Round to the third, look at the next, 6 is larger than 5, therefore we will go ahead and round up. So this will be 7.78, in this case 7. Round to the third, look to the next. Oops, a bit backwards. Okay, so round to this place, look to the next place. This will bump it up. Now this 9 will also now in turn round up the next number in front of it, and so this will be negative 0.010. Now we do need to put that last 0 on there, even though it is a 0 and technically has no value. We are asked to round to 3 decimal places, so we have to show 3 decimal places. Here we're being asked to simplify some algebra, so let's go ahead and do that. My strategy is to round or do this a little bit at a time. So I'm not even going to deal with the squares right now. I'm just going to go ahead and round what's in the simplify what's in the parentheses. So here we do have a 4, then we have a negative, negative 1. Keep in mind 2 negatives make a positive, so this is negative 4 plus 1, or just a negative 3. Here we have a negative 6 plus 2, that'll end up being a negative 4. Now we have parentheses squared. The fact this negative actually now doesn't matter because we have parentheses squared. Remember, this does not mean times 2. This means negative 3 times itself twice. So negative 3 times negative 3. That'll end up being a 9. We have negative 4 squared. Again, negative 4 times negative 4. Ergo, it's 16. And so when we have the square root here, we'll have square root of 25, and that'll end up being just 5. Hey, I know what you're thinking. You may say, well, if in a square root, isn't it plus or minus 5? In this case, it's not. The reason being is because the original square root was not, it didn't ask for a positive, negative square root. It had no symbol, so this applies just a positive version of it, in this case, just 5. If you apply a square root in problem solving, then you're going to have to use both the positive and negative versions in your answer. Let's go ahead and look at this next one. Same tactic. I'm just going to simplify what's in parentheses first, and then I'll square it later. Here we have negative 4 minus 8. That's going to be a negative 12. Then we're going to add negative 9 minus a negative 4. Again, that's positive. That's negative 9, essentially now plus 4, or negative 5. Here again, we have the negatives that they're trying to trick us with, but we won't be tricked by that because that's negative 12 times itself. That'll be a positive 144. And then we have negative 5 times itself, which would be a 25. So adding these together, this will be 169. The square root of 169, what number times itself is 169, is a 13. Again, just a positive version because the square root at the beginning was just the positive square root. Moving on to slopes. So this is really just recognition of form. So this first one is in y equals mx plus b form. In this form, the m version, or the m letter, excuse me, is that slope, and so the 4 will be that slope. And so the slope in this case is just 4, or if you want to be Mr. Cool Guy, it'd actually be 4 over 1, because slopes probably always should be viewed as a ratio. Here we have, again, another form. Now you could take a couple different tactics. You can convert it back to this form if you want. In other words, kind of solve it until it's mx plus b form. Or you can recognize that this is actually a form in itself. This is point slope form. Make your Algebra 1 teacher happy. And in this form, the slope actually occurs before the x minus x1 parentheses. And that means that's the slope right there, so m is just equal to negative 2/3. Again, a good tactic would have been like to take this equation, make it back in mx plus b form using some algebra, but in the end, if you can read it, it's going to be just as fast. Equally good skill here, let's take the slope off of the grid. So this entails really just kind of taking a couple good points at some intersections and looking at the steps. And so to get from point 1 to point 2, we have to go down 1 unit, and then we have to go over 2 units. And that means our slope has to be negative 1 over 2, because we know the slope is rise over run, or change in y over change in x. In other words, up and down before left and right, making our slope negative 1 over 2. Negative fits because the line is going down instead of up. Ergo, it should be a negative slope. Okay. Here we have the points. Here's really where we're going to work that slope formula. So I like the slope formula as change in y over change in x, because I recognize that is an x point, that is a y point, that is an x, that is a y. I can quickly look at the jumps. So the y goes from -3 to 7. That's a change of +10. At the same time, it goes from 9 to 2. That's a jump of -7. And so my overall slope is just going to be -10/7. There's more than one way to do that, but I think that's by far the fastest way. There is a slope formula, which is y2 minus y1 over x2 minus x1. And so depending on what your teacher said to do in algebra, either one of those would be viable. Last one, let's do some equation solving. So this kind of crazy looking thing is really not that crazy. You know that you probably have to do some simplifying through distribution first. But once you do that and get negative 2x minus 12, we'll see that this side is just going to be half of 4x, which is 2x, and half of 4, which is 2. Now we're just into our normal solving stuff. Move all the x's to one side, so I'll add 2x to both sides. And at the same time, we can go ahead and subtract off the 2 and move it over to the left. The result of that equation then, those are gone. This will be negative 14, and that will be equal to 4x. So now we're down to the one-step solving. If I want to get 4x by itself, it is be multiplied by a 4. Certainly we will divide by 4. Leaving our x number on the left, negative 14 over 4, we can cut that in half, make it negative 7 over 2. Or if you use a calculator, I guess you can say it's going to be negative, what's that, 3.5 to make x. Either one is totally acceptable. I prefer the fraction, so does mathematics, but it's up to you. Here we have to do some evaluating. So we defined f of x. If f of x is defined by this function, and we have the input value of 2. And so we can rewrite this as f of 2, meaning that we replace all the x's with a 2. And so now we have f of 2 is the same thing as 2 times 2 minus 10. So that'd be 4 minus 10, meaning f, when we replace x with a 2, is equal to a negative 6. Last one, again, solving for x here. Just because it's a square doesn't mean that we do anything really different. We're just trying to get x by itself. So the first thing we can do is divide by that 2 value. Those are gone, leaving us with an x squared. 72 cut in half is 36. So now as far as what we do next is we have to get rid of that square. But again, just like addition kills subtraction, multiplication kills division. If we have a square we need to get rid of, then we can simply square root, as long as we do it to both sides. What's left then is the x value just being equal to the square root of 36, which you may say is 6 because 6 times 6 is of course 36. But if you recall what I said kind of about these first set of problems, there is more than one thing times itself that makes 25. It's not just 5, but it's also negative 5. And so when you go to this problem, we do have to, in this case, consider the negative version as well. And so x can be equal to 6, or x can be equal to negative 6. The reason we look at both in this situation and not the previous one is if you look at the problem, it didn't start out with a square root. We had to bring in the square root in this step to actually solve. So we don't know which one the problem actually demands because they both work equally well. It wasn't like this first problem that kind of told you right off the bat, just consider the positive square root because there was no negative. This one doesn't tell you that, ergo you have to include them both. And so a quick algebra review, that's going to be a commonplace thing on this homework, and yes, it will be a commonplace thing on the test too. Right? So that's part 4. I'll do a similar thing for the second homework, and that will be posted ASAP.